Hello and welcome to today's class. For this class, we'll be considering the second concept under the study of work done, energy, and power. In our last class, we spoke about the concept of work done. So I'll drop the link to our first class on work done. As you can see the link above you here, I'll drop the link above you here. All right, let's discuss the second concept called energy. In our next class, it's about the concept of power. Let's dive into the study of energy. What is energy by definition? We all know that energy is simply the ability to do work or the capacity to do work. Now, what we are diving into majorly now is the forms of energy. When it comes to forms of energy, there are about several forms of energy, ranging from mechanical energy, solar energy, light energy, um, atomic energy, chemical energy, and etc. There are much forms of energy, right? So let's start. But majorly, we'll be discussing about one forms of energy called the mechanical energy, right? Let's start with the first one there, called all right. When it comes to forms of energy, there are about several forms, but we consider majorly what we call the mechanical energy. After defining energy and listing out several forms of energy, let's discuss mechanical energy. What is mechanical energy by definition? Mechanical energy is simply the energy possessed by a body either at rest or in motion. That's the definition for mechanical energy. When it comes to mechanical energy, there are two types of mechanical energy. We have the first one called the potential energy, and we have the second one called the kinetic energy. Let's discuss the various types of mechanical energy. Number one, we called potential energy, and the second one is called the kinetic energy. So these are two distinct types of energy that we have, ranging from the potential energy and kinetic energy. Let's discuss this energy one after the other. Let's have the first one called the potential energy. Potential energy. All right, let's define the concept behind potential energy. By definition, potential energy is simply the is also potential energy is also called PE, right? Potential energy is also called PE. It is the energy possessed by a body by its virtual of its position or state. It can also be defined as the energy possessed by a body at rest. So whenever energy is being done by a body at rest, it's said to be what? Potential energy. Mathematically, mathematically, potential energy PE is equal to mass times gravity times height. This becomes the mathematical expression for potential energy. That the potential energy of a body is simply the product of the mass of the body, the acceleration to gravity of that body, and the height attained by the body. That's the concept behind potential energy. All right. I want to understand the concept behind definition of potential energy. There are about two forms of potential energy. Let us call the forms of potential energy. When it comes to the forms of potential energy, there are about two forms of potential energy. The first one is called the gravitational potential energy, and the second one is called the elastic potential energy. So we have the first one as gravitational potential energy. Let me use PE. And number two, we have the elastic potential energy. So these are like the two forms of potential energy that we have, ranging from the gravitational potential energy and the elastic potential energy. Let's discuss this concept one after the other. Let's start with the first one called gravitational potential energy. By definition, gravitational potential energy is simply the energy possessed by a body placed at a particular height. So whenever a body is placed at a particular height, the kind of energy possessed is called the gravitational potential energy. So let's say I have a cupboard this way. I have a cupboard this way, and I have a particular object here, a mass of an object. We know that from here to here is what? The entire height. So I'm telling you that gravitational potential energy is equal to mass times gravity times height. This becomes a mathematical expression for calculating the concept behind gravitational potential energy, GPE, gravitational potential energy. This is a particular expression for calculating any concept under gravitational potential energy. Let's call the second form called the elastic potential energy. Elastic potential energy. By definition, elastic potential energy is simply the energy that occur within a spring. Let's use a spring, right? For instance, let's say I have a fixed what's it called? A fixed point this way, and I have a spring. Let's use a spring this way attached to a particular object. This one here is the spring, right? So this is the mass of the body. So now the mathematical expression for elastic potential energy, that is P E E, that is elastic potential energy, is equal to half F E. What is F? Force. E is called extension, right? E is called stiffness of spring. So E is called the stiffness of spring, right? So from the concept of Hooke's law, we know that this force is equal to Ke. True or false? True. What's it called? Ke, right? So it means that from here now, it means that my gravitational elastic potential energy will be equal to half into what's F? Ke. That's Ke multiplied by this E here. So from here, the mathematical expression for elastic potential energy becomes half Ke squared. E times E becomes Ke squared. This becomes so this is force, right? This is force. This is extension, right? Extension E. Why K is called stiffness. So this become K is stiffness of spring. E is extension, while F is force. So let's discuss the second concept behind the types of mechanical energy called the kinetic energy. For kinetic energy, by definition, kinetic energy is simply the energy possessed by a body by its virtue of its motion, right? Whenever It can also be defined as the energy possessed by a body in motion, right? So that's the concept behind kinetic energy. Mathematically, kinetic energy is equal to half mv squared. The short form of writing kinetic energy is what? Ke. While potential energy is what? Pe. So we are saying that mathematically that potential energy kinetic energy K is equal to half mv squared. That the kinetic energy of a body is simply the product of half and the mass of the object and the velocity with which the object moves. So it means that m represents mass measured in kilogram and v represents velocity measured in meter per second, as you can see in front of you. Let's now use all these concepts here to solve some problems, and let's see how we can apply these terms or perhaps the conditions here to solve some past questions. Alright, welcome back. Let's use all this idea now to solve some problems, and let's see what we get. Example 1 says, what is the potential energy of a body of mass 10 kg standing on a building floor 10 meter above ground level? So let's try to solve this problem here. When it comes to solving problem on physics, your first task is to list out the given parameters. What are you given? So solution here, my first task in that question is that number 1, example 1, is that I'm saying I'm given that what is the potential energy. So I'm trying to calculate PE, potential energy is unknown, of a body of mass 10 kg. I'm given mass, that's m, that's 10 kg, standing on a building floor of 10 meter, that's height, please, that's height, h, that's 10 meters, so above the ground level. So when it comes to, listen please, when it comes to the mathematical expression for potential energy, I gave you 2, and observe that those 2 are the same. Yes, I give you 3 per se, 3. Number 1 is the real mathematical expression for it, which is mass times gravity times height, and I give you for potential energy for elastic and gravitational. Observe that the real formula for potential energy and the gravitational formula are the same thing, but the difference is what? The elastic potential energy is different. That's half k e squared, right? That's the mathematical expression for elastic potential energy, right? So for this one now, my concept is to apply the real mathematical expression for potential energy. So from here now, recall that potential energy is equal to mass times gravity times height. So in most cases here, I'm given height, no problem. I'm given mass, no problem. What's the height? Gravity. That's the question. So gravity can either be 10 meter per second squared, or gravity can be 9.8. In this case here, meter per second squared. Let's try to use 10, right? So if you are given a question, you use the one that are given, but in this case we're not given, you can choose any one. So it means that my potential energy is equal to mass is 10 multiplied by gravity, let's use 10, multiplied by the height, h, that's 10. So from here now, potential energy is equal to 1000 joules, please. Note that potential energy and kinetic energy are measured in joules, right? So they are measured in joules, so that becomes 1000 joules here as my answer to that question there. Alright, let's try to solve the second problem under this concept and hence today's class. Example 2 says an object of mass 5 kg is moving with a constant velocity of 15 meters per second. Calculate the kinetic energy. So let's get it done, please. Solution. First things first, list out the given parameter. An object of mass 5 kg. I'm given mass M as what? 5 kg is moving with a constant velocity. That's V. Velocity V of what? 15 meters per second. Alright, calculate the kinetic energy. That's Ke is unknown. What we know before now, recall that we said earlier that Ke is equal to half mv squared. Am I given mass? No problem. Velocity? No problem. So let's get this done, please. From here now, my Ke, which is kinetic energy, is equal to half times what's my mass? That's 5 times what's velocity? That's 15, but what? All squared. If I express this one here, kinetic energy is equal to, multiply this through, I'll have 562.5 joules as my answer to this question here. So this is how to calculate for this problem using the concept of energy. So see you in our next class. Before you start watching any of our video, try to watch the video at least for 5 minutes before you download. It helps the growth of our channel. So if you're interested in helping us to grow, try to watch our video at least minimum 5 minutes before you start downloading and watching for later purpose. So see you in the next class when we're discussing about power as next concept.